Hi, I'm Rob, and I'd like to welcome you to this video where we'll train, make predictions, and evaluate Scikit-learn, GradientBoostingRegressor, and RandomForestRegressor models against the California housing dataset. To get started, make sure you have the appropriate libraries for this demo installed. For the demo, I'll be using datasets from Scikit-learn, the linear regression model, GradientBoostingRegressor model, and RandomForestRegressor model. We'll also use PolynomialFeatures to improve the performance of the linear regression model. We'll need the train, test, and split module from Scikit-learn model selection to split the California housing dataset into train and test sets. And we'll need the R2Score module from Scikit-learn metrics to evaluate the model performance. Pandas, Matplotlib, and Seaborn will be used to plot a correlation heat map of the California housing dataset features, and we'll use JobLib to export our trained model. So I'll go ahead and execute the code in this cell, and then define a function which will plot the correlation matrix, taking the housing data frame, which we'll create in the cell below. So I'll go ahead and execute this. And then from the Scikit-learn datasets, I'll call the fetch California housing method and store the data in a housing data frame. Then we'll print the shape and feature names and pass the data frame to the function to display the correlation matrix. So let's execute this. And here we see the shape of the data frame has 20,640 records with 8 columns. And here's the correlation matrix. Now I'll define several utility functions which we'll call when working with our models. The first will be to set the features and target variables from the housing data frame. So here I'll declare x and y variables where x is the data or the features in the data frame and y is the target. Then we'll print some information about x and y and return the values. So let me go ahead and load this cell. Next is a function to split the x features and y target variables into training and test datasets. We'll use the train test split module, passing x and y with a test size of 20%, which will put 80% of the data in the training dataset and 20% in the test dataset, and set a random state, which will ensure reproducibility when executing this function. We'll print some data on the test and training datasets, and then return the results. So let's load this cell. Next is a function to train the model, which takes the X training data and the Y training data. This particular function will use the linear regression model and calling fit on the model, passing the X and Y training data will perform the model training, and then we'll return the model. So let's load this. The predict function takes the model and the X test data, which is passed to the predict method on the model to make a prediction on the test data set. We'll load this. And then the evaluate model function takes the Y test and Y prediction data, and we'll use the R2Score module, taking that data to calculate an R2Score, print it, and then return the value. Where the R2Score tells you how much of the variation in your data is explained by the model. So we'll load this, and then move down to the cell where we'll train and evaluate the baseline linear regression model performance. So the first thing I want to do in this cell is get the values for x and y, the features and the target. And I'll do that by passing the housing data frame to the set features and target variables utility function above. When I have the data for these variables, I'll pass it to the split data function, which will give us the x train, x test, and y train and y test data sets. Then I'll take the x train and y train data and pass it to the train model function, which will return the model. Then I could call the predict function, passing it the model and the x test data, which will give us our y prediction. And finally, pass the y test and y prediction data to the evaluate model function, which will give us the baseline R2 score. So let's go ahead and execute the code in this cell, and we see our R2 score is 57.8%. And again, this value tells you how much of the variation in your data is explained by the model. So let's scroll down to this next cell. And what we want to do is use the PolynomialFeatures module, calling the fit transform method, passing the value of x which is returned from passing the housing data into the set features and target variables function. This will add additional features to our X data frame. So first I'll print the current shape of the data frame and then the shape after the transformation. So let's go ahead and execute this. And we see the shape before was 20,640 records with 8 features, and after we have 45 features. Now in this next cell, we're going to train and evaluate the model performance with the polynomial features, which should give us an improvement in our R2 score. So let's go ahead and execute this code. And we see we now have an R2 score of 64.57%, which is a 6.99% improvement over the baseline R2. Next, we're going to use the GradientBoostingRegressor and RandomForestRegressor modules. But before we execute those cells, I've created a new train model version 2 function, which takes xtrain and ytrain, as we saw before, but now takes the model. So I could call fit on both the gradient boosting and random forest regressors when the function is called. So let's go ahead and load this function. And for the gradient boosting regressor, I'll pass the housing data frame to the set features and target variables function to get the values for x and y, then pass those values to the split data function, which will give us our training and test data. Then I'll call the train model version 2 function, passing it an instance of the gradient boosting regressor and the xtrain and ytrain datasets. Once I have the model, I'll pass it to the predict function with the xtest dataset to get our prediction, and then evaluate the model performance and print any improvement over the polynomial R2 score. So let's go ahead and execute the code in this cell. And we see our R2 score is 77.5%, which is a 13% improvement over the polynomial score. And for the random forest regressor, we'll once again get x and y, then our training and test data sets, pass an instance of the random forest regressor, setting the n jobs property to -1, which will use all available CPU cores, making the training faster, which will return the model. Then we'll make our prediction, evaluate performance, and print improvements over the gradient boosting score. So let's execute this. And we see this R2 score is 80.5, which is a 3% improvement. Finally, what I want to do is call the dump method on the job library, passing it the model and the name of the file that we want to export our trained random forest model to. So before I execute this, let me jump over to the home screen in Jupyter, and we see I currently only have the demo IPYNB file. So if we execute the code in the cell, we see the file was created, and jumping back to the home, we see the joblib file here as well. Now I'll call load on joblib, passing it the name of the joblib file, and putting the data in the California Housing Price Predictor model variable, and then pass that in the xtest dataset to the predict function, which will give us our prediction that we can send to the evaluate model function and generate our score. So let's execute this cell, and we see the R2 score for our saved model is the same R2 score that the random forest model produced before we exported it to the joblib file. So that concludes this video on training, making predictions, and evaluating sklearn, gradient boosting regressor, and random forest regressor models against the California housing dataset. If you found this video useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.